Okay, Lila, we are going to do a couple problems. Actually, we're going to try to do four problems at the bottom of the first page that you had sent me, Chapter 4, Cumulative Review. First, we're going to start with problem number 51 here. Problem number 51, actually 51 through 54 says we're going to write an equation of the line given that we have this information. We have a slope and we have an intercept, a y-intercept. And we are going to, it doesn't say, just says write an equation. The easiest way we're going to approach this is to, since it's given us a slope and y-intercept, we're going to do it in slope-intercept form. And we remember what that is, y equals mx plus b, where this m is your slope, this b value is the y-intercept. And again, the y-intercept just being the point at which that line, that function crosses through the y line or the y-axis, which is going to be this guy right here, right? This y-axis. So for our first one, let's do we're going to do number 51 and 53. We'll start with 51 here. 51 gives us a slope of 4, the y-intercept of 12. Now, when we do this, we want to start with our benchmark. Our starting point is going to be that y-intercept. Okay. Now, if we don't know how to fill this in straight up from the equation, we can at least start this. We can say y equals something, right? And then we have to fill in the right side. Well, the intercept is given as 12, which is where? That means we are right here, right? 0, 12, the coordinate 0, 12. This guy right here. Remember, your x on the xy is going to be 0 when we're talking about the y-intercept. So that coordinate, as we're looking on the graph, or on a graph, is 0, 12. That's what the coordinate is. But how we write an equation, we're looking at, this would be the b value, right, of that equation. So that's going to be a plus 12 there, positive 12. So we got half of it. What about this part of it, the mx part of the equation? Well, we look at the slope given. The slope given is 4, and we know from our equation, y equals mx plus b, that m is the slope. So I'm just going to write in 4 for m, and then my x placeholder is right after that, 4x plus 12. So for 51, that would be y equals 4x plus 12. And we could plot that out on the on the graph here, and don't necessarily need to for this, but we'd know how to do that, right? When we met together, we'd go up 4 and over 1, up 4 and over 1 as we go to the right, and then we plot a line there. How about this next one? We're going to do 53 here. 53 says we have a slope of 1/2. We have a y-intercept of -2/5. So this time, both values are fractions, but we can still do that. That's fine. We start with our y for our equation. They want an equation. Y equals something. So we have to fill in the blanks of the right side, right? We have m is some kind of blank, x, and it's either really a plus or a minus something, right? It's either a negative value for intercept or a positive value. Well, let's fill in those blanks. Let's see. Well, let's start with the slope this time. Let's start with the slope. So this guy, what is that value? Well, they give it as 1/2. and it's a positive 1/2. So this guy right here would be a positive 1/2 x. Let me, in fact, let me write that down. I'll take those blanks out of the way there. We'll rewrite that as 1/2. The x is on the outside. You could put x over 2 if you wanted to. That's the same thing. X over 2 is the same as 1/2 x. But we'll just say 1/2 x. And then what do we have? Is it a plus something or is it a minus something? Well, it's the y-intercept for this is given as negative 2/5. So we have a negative. We have a minus instead of a plus. The last one we did, 12, that was a plus. This time we have a negative. So we're going to put in a minus 2/5. And if we're not sure if it should be minus or plus, we can do our little check of putting in x at 0, right? Where x is 0, we would have the y-intercept. So what is that? Well, if I put x in for 0, 1/2 times, I'm sorry, 0 in for x, 0 in for x. I have 1/2 times 0 minus 2/5. That's what I wrote down. Will that give me a y equals negative 2/5? Let's see. Well, that would be y equals 0 minus 2/5. And lo and behold, that would be y equals negative 2/5. So there we go. So that checks. And where is that on the graph? We don't need to know that necessarily, but where would it be? Well, it'd actually be down in this territory, right? Because that's on the negative side of for the y-axis, because we're at a negative 2/5. I'd have to close up, but it'd be right in between 0 and negative 1. It'd be a little less than 1/2. Negative 1/2 is where we would cross the line there. Okay, for this next one, we're gonna do number 55, where we're given a graph this time with the line. That is this guy right here, right? Number 55. And we want to write the equation of the line in slope-intercept form, given the graph, given the line that's presented. I'm gonna move this guy up here so I got some room to write. So we're on number 55 here. Well, what do I need in order to do this? Well, I need these guys down here, right? I need to look at my equation first. Well, my equation's y equals mx plus b. Slope and intercept are pointed out there. Y-intercept. So what would those be? Do I have enough information? I have a y-intercept right away here, right? What's that? That is the point at which 0, 2 is the point at which that line crosses or intercepts the y-axis. Okay, that's 0, 2. So my b value for this guy is going to be a positive 2. Why is that? Because it crosses at y is positive 2. Okay, remember this 0 here is for x and the 2 is for the y, for the coordinate there. Do I have a slope? I can determine the slope one of two ways. The easy way would just be to figure out rise over run. I could actually count the units from one point to another. And let's just use these points here because they are certain points. I mean, they're points that are for certain, are crossing at a, like an integer, like at a round number. Whereas, if I'm over in this area between, kind of between 2 and 3, so I kind of got some fractions. So I'm not quite sure what's going on between, but I know for sure that these are crossing at 2 sure coordinates here, right? 0, 2, and it crosses up to 4, 3. If I just count the rise over run, my rise would be 1, positive. My run would be 3 units. I'm sorry, 4 units. 4 units. So my rise is 1 unit. My run is a positive 4 units to the right there. So what is that? M is equal to 1 over 4. How would I write that? Y equals M is 1 over 4. So again, this is for number 55. 55. Y equals M1 over 4, X plus 2. Plus 2 was my y-intercept. What is another way that I can determine the slope? Well, I can determine in this fashion. My change in y over change in x. Remember, that's what the calculation is, or the equation is. Well, how would I figure out my change in y? Well, I could figure out the change in y between 2 coordinates. We'll call it y2 and y1. That difference, y2 minus y1, over x2 minus x1, the difference of the x coordinates, x2, x1. Well, where do I get those? Well, I can get those from these coordinates here that they happen to point out, 0, 2 and 4, 3. So let's just call 0, 2 x1, y1. And let's call 4, 3 x2, y2. Oops. My stylus isn't doing very well here. There we go. So x2, y2, I'm defining as 4, 3, x1, y1 as 0, 2. You could change it around. It doesn't matter. You just got to make sure that this equation here that we use, you're using the proper order. Okay, if you use y2 at the beginning minus y1, you got to use x2 at the beginning minus x1 on the bottom. So what does that mean for us? Well, y2 for us was 3 in 4, 3. Y1 for us was 2 in 0, 2, that coordinate. So 3 minus 2, that difference. X2 for us was 4 in 4, 3. X1 for us was 0 in 0, 2, right? That coordinate. So that difference is 4 minus 0. Well, what is that? 3 minus 2 is 1. 4 minus 0 is 4. And look at that. We have the same value. Whether I pick it off the graph or I calculate it, it's still 1 over 4 for the slope. Okay. Let's look at the next one here. Number 56. 56 says we have a graph here. It looks like it's a line that's going down, decreasing slope, going from 0, 3 to 1, negative 3. Well, our y-intercept, where it crosses the y-axis, is where? It's right here. 0, 3, 3 being the y value of that. So we have a positive 3 there, positive 3. What about the m value, or the slope? Again, we can calculate it, or we can just count it off. Let's go ahead and count it off. So what's our rise? Well, it's actually a negative rise. It's a downward. We go down 1, 2, 3, 4, 5, 6 units as we go from coordinate to coordinate. So we got a negative 6 there. And we have a run of 1. Negative 6 over 1, or we can just say negative 6, either way. Now, what would that equation be? Well, the equation we want is y equals mx plus b. Our m was negative 6x. And is it a plus or a minus? Well, it's a plus here, right? Plus 3. Our b, or our y-intercept, was 3.